That cylinder gets power, it moves down. Comes at the bottom, touching the bottom switch, it applies power, it makes a weld for some time. When it's finished making the weld, it moves back up, touches the top switch, puts power on the motor. Then it moves to the next point. And it repeats it until every time it comes back and it closes that switch, we're going to add one to a counter. When the counter is done, we know we've done all the welding spots that we want to make. Then, when the counter is done, it says, now turn the motor the other way and move back. And there will be another timer that controls how long it is moving back. Now, those tables that you've got in the book, page 70, what? Page 75. First of all, we've got 3 buttons. Start button, that's the inputs. We've got 3. Start button, switch 1 and switch 2. Now if you look at the drawing, which one is switch 1? Switch 1 is the one on top. That is switch 1. And the bottom one is switch 2. Those 2 are controlling. Switch 1 is controlling when this motor must get power. Switch 2 is controlling when it must start welding. Okay? I'm not going to put in the addresses. Then, outputs. We've got 4 outputs. Weld controller, motor left to right, motor right to left, and the weld cylinder. The cylinder, this cylinder here. So on the outputs, there are 4. The first one there is the cylinder. That is that cylinder there. What is that cylinder's job? To move the welding rod up and down. Okay? Then we've got the motor going left to right. One contact that will apply power so that the motor can go that way. Then we've got the motor coming back. And then lastly, we've got the welding, which is putting power on while it is at the bottom. Okay? Then there are some timers. There are 3 timers. There's one of them that's got the wrong value, which I will show you, and there is a correction. There are 3 timers. The first timer is controlling, I just want to put them in the same order here, the weld time. Weld time. And that one is the one that puts power on while it is at the bottom to say how long must it weld. And that one is T41. And then we've got time between welds. T4:1. Between welds. What that? T42. What is that going to do? That is the one that will put power on this motor. Putting a time on to move it to that. To move to there, to move to there, etc. So that is between welds. Then the last one is the return motor. Is that correct? Correct? Yes. Return. Return, 343. Can you see that this return must be the same as that plus that plus that? Am I right? It's going forward, that plus that plus that. When it goes back, it must go that time back. So this return will be a multiple of that one between welds. This one is moving that direction, this one is moving back. Okay. And that's where the mistake in the values comes in, I will tell you just now. And then we've got a counter, which counts the number of welds I want to make. Number of welds. C5:1. That's the number of welds. Okay. There are two binary values as well, which I'm not even going to look at this time. Let's just look at what we've got here. Start button controls when I press start. Switch 2 controls when it must start welding. So switch 2 is going to put power on that one. Switch 2 is going to put power on that one to say it must weld. When that one is finished, it will put power on the cylinder to go back up. Then, when it touches switch 1, it's going to put power on moving forward so that it can move to the next welding point. And that is controlled by this timer, T42. When T42 is finished, it puts power on the cylinder again. So T42, when it's finished, puts power on that cylinder again, so that it can go down. When it comes at the bottom, it closes switch 2. It welds. When it's finished welding, the cylinder goes back. It touches switch 1. And every time it touches switch 1, it adds 1 on the counter. When the counter is done, then it puts power on the return motor. Have you got it? Now, if you look at the circuit, that's why I said sit with somebody that's got a book. If you look at the circuit, line 0 is just controlling the welder cycle. When switch 1 is closed, after closing switch 2, the condition is remembered in a binary value. And then we have got the 3 timers, TON, CTU, and you can see CTU gets its power when T41 is done. So every time it is finished welding, it adds 1 on the counter. And then it repeats. Now, where do you get the times from? First time that you need is, how long does it stay welding? Which one is the weld timer? T41. Look in the drawing. What is the preset and the time base of T41? What is the preset and the time base of T41? Look in the drawing on page 77. Then find T41. Tell me what is the time base and the period. Sorry, the time base and the preset. Where's T41?
95.
There it is. It's line 3 of the diagram. What do you see? Time base, 01. Preset, 250. What is the period? So that T41 is 0,01 times 250. That is 2,5 seconds. Huh? What is period? Time base multiplied by preset. 0,01 times 250 is 2,5. So that means it's staying down here 2,5 seconds to weld. It's going to stay there 2,5 seconds to weld. 2,5 seconds to weld. 2,5 seconds to weld. Right? How many welds are we going to make? What is the counter preset? Check. What is the counter preset? 5. And every time it finishes a weld, it's adding 1. So the counter C51 will be 1 when it's finished here. It will be 2 when it's finished there. It will be 3 when it's finished there. It will be 4 when it's finished there. So it's going to make another one there, 2,5 seconds. So it's going to make 1, 2, 3, 4, 5 welds. Okay? Do you agree? Now, how far apart are those welds? What controls that time that the motor takes to move from one weld to another one? It is T42, which puts power on that motor. And that determines how far the motor will move. Now, find T42 and tell me what is the time base and the period. Sorry, the time base and the preset of T42.
Time base is 0.01.
T42, 0.01 and 180. Huh? 0.01 times 180. So that is 1,8 seconds. Isn't it? So it's going to move forward here. 1,8 seconds. Then 1,8 seconds. Then 1,8 seconds. Then 1,8 seconds. Is that correct? Huh? Now, when it is finished, when the counter is done, it puts power on the reverse motor. And there's a mistake in the book on this one. How long must it go back when it goes back to the starting point? 1, 2, 3, 4 times 1,8, isn't it? So it must go back 4 times 1,8, which is what? 7.2 seconds. So in the textbook, it says there 900. It must not be 900, it must be 720. Huh? Do you see why? T43 must be 0,01 times 720 to give you 7,2 seconds. Do you see it? So that 900 is wrong. It must be 720. So fix it in your book. T43 preset must be 720, not 900. Right? Anybody that has got a problem with the times that I've written here on the drawing? Yes. I'm coming to that. I'm coming to that. Everybody understand that it's going to take 2.5 seconds to make a weld. What is that controlled from? T41. Okay? Then it's moving forward between welds by turning this motor in one direction. And it's turned for a certain time controlled by T42. Every time it's finished making a weld, it adds 1 to the counter. When the counter reaches the preset value of 5, then it goes back. And going back is controlled by T43. And going back must be the same as going forward. Okay. Now we come to the calculations. I add one more thing. I say for this cylinder to move down and to move up takes 0,5 of a second. To move down, 0,5 seconds. To move up, 0,5 seconds. Okay? Now I'm asking you, what is the total time from the time that I press the start button until the job is finished? And what is the total time to complete the job? Now, before I start doing the calculations, is there somebody that wants to ask a question before I start? Explain. Okay. I've got a question. Why do I want to know what is the total time to complete the job? Why is it absolutely important to know the time to complete the job? Huh? Production cost. Thank you, sir. If I ask you, I say I've got everything at home, but I've got a job there. Come and have a look at the job and give me a price. On what are you going to base your price? Isn't it on the time that you're going to take to do the job? If that job is 2 hours, and you putting your own time at 120 rand an hour, you're going to charge me 240 rand to do the job for you. Isn't it? So, the same here. This job is done in a factory. I need to know what is the time and at what rate am I paying that person doing the job, so that I can work out the person that's going to pay me for doing the job. How much must I charge him for labor? Apart from I'm using so many welding rods, I'm using so much electricity, my wear and tear on the machine, paying for the secretary, paying for the manager that's not doing production, plus profit, plus labor. There's my price. That's how you make a price, isn't it? And we need the time to complete so that I can work out what is the labor cost. Right, how am I going to work out this total time? What times do I have? I've got, firstly, I've got this thing moving up and down. That is how much time? 0.5 plus 0.5. And how many times is it moving up and down? 1, 2, 3, 4, 5 times. But I can get that from here. That preset. Times 5. So that is 5 seconds. Isn't it? That's an up and down. Then I've got the weld time. How much is every weld? 2.5 seconds. Where do I get that from? From this one. 2.5 seconds. And how many welds is it making? 1, 2, 3, 4, 5. That value. Times 5. That is 12.5 seconds. Right? Then I've got the forward motion. That is 1.8 times how much? 1, 2, 3, 4. Because it's not going to move the 5th time, it's going to come back. So that is 5 minus 1. So it is 4 times that. That is 7.2 seconds. Then I've got the reverse time. And that is this one, T43, which is again 7.2 seconds. And that gives me the job time. And that is 14.4, 26.9, plus that 31.9 seconds. That is the job time. If I take in practice that it's going to take another 2 seconds, 3 seconds, 4 seconds for the guy to take out the job and put the new job in, it's going to be about 40 seconds. But this is the answer I'm looking for. But in practice, it's going to be 40 seconds to complete one job, because he's got to take that one out, put the new one in before he can press the start button again. So, in an hour, that person can make how many? About 65 jobs. So, if I pay him 250 rand an hour, then I can divide that 250 by 65 and say this is the labor cost for every job that I'm doing. Have you got it? Now, what questions are you going to get? You get the sketch, you get the tables, you get the logic drawing. And then I say, I change the preset value of T41 to 220. I change the preset value of T42 to 110. I change no, that's all I'm doing. I change those two. Then I say to you, I want the total well distance to be about the same or slightly less. Or I can say the same or slightly more. Calculate the new value of C51. Calculate the new value, preset value of T43. Calculate the completion time to do the job. That I will do tomorrow. And then we are finished with this, because I want to do two of those calculations. Basically I'm going to change that and that, those two presets, and I can change these values. I change those values here, and I change the preset values there and there. You've got to calculate this value, that value, and this value. That will be in the exam. Okay. Maybe also in test 3. The reason why I say maybe in test 3 is because if I want to ask this question in test 3, I've got to print 70 of those pages. But I think I've got it. Maybe I've got 50, I must print another 20. Any questions now? You can look at that drawing and see if that drawing is doing this job. The explanation of the drawing is given next to the drawing on page 77. That will finish, so tomorrow we will finish this chapter with the change calculations. And then next week, if you look at the next chapter, it's only 4 pages. Chapter 6. 1, 2, 3, 4, 4